This is another example talking about inverse, so let's take a look. A will be very simple, talking about A squared A inverse. But if it is asked in this way, then I guess there should be a relation between that, or else they won't be put in together in part A. Which means I don't think that in this question I'm going to apply 1 over determinant of A multiplied to adjoint of A, because it may not be it doesn't look like a question that you find A inverse directly. Let's see whether my guess is correct. Okay, A will be very simple. A squared will be, because this one is not a diagonal matrix, as there is a 2. So you can't use the feature of diagonal matrix to do the multiplication, but you are going to do a very standard way to multiply the matrix by doing row and column multiplication. So now you have 1 0 1 2, which gives you a 1, 1 0 0 minus 1, which is a 0. Okay, so second row, 0. Up to this, I guess, is it an identity matrix? Probably yes. So finally, second row, second column, which gives you a 1. Yes, bingo. And you find that it is equal to Ri. So this is the trick of the question, which explains to you why A inverse is put in part A. So that's why I don't think that. So we are applying the definition of inverse to do so. And then now you will see, not part B. Now you will see that, okay, because A squared, or that means A times A is equal to I, that means A inverse by chance is equal to A directly. Because the A is a partner of A, so that it gives you a inverse. So that's why the A inverse will be 1 0 2 minus 1 as well. So, quite a funny result, right? So this is the situation. Next, we come to the second part. Second part will be a very little trick on how you make use of the I to find the part N in a very easy way. Because now you can see the pattern. Okay, that means you're going to think or observe the pattern like A is A, right? A squared is a I. A cube, you can see is A squared times A. Because of the existence of I, that means it goes to A. You continue the process, then A to the power 4 should be a I, A to the power 5 is a to the power 6 is a I, etc., etc. So it's like talking about a change of the values or the results alternatively in this case. But now because n itself, I don't know what's the value of it. So in this case, then we can only present like A to the power n carries 2 results. One may be an A, and the other one is an I. It is a very new presentation of an answer to you, because it usually asks in the past in pure math when we want to present the answer in different ways. So you will see when n is odd, then you have the answer A, whereas when n is even, then the result is an I. So this is the answer for part B. Okay, finally we come to part C. So it seems to a terrible one, A inverse to the part N. So once again talking about part N. Okay, but now you can see the situation. A inverse will be equal to A. That means now part C will be A to the power N indeed. So that's why the question is identical to part C, whereas you have 2 different results. It may be A or it may be I, regarding to the nature of n, whether it's an odd or when n is an even number.